We're back. Another lesson with Jake for calculus. Solving differential equations today.
Thanks, Jake. So sometimes, or very often maybe, the only known information in an application involving two variables is how the rate of change in one of the variables with respect to the other relates to the other variable and or itself. I really should have reworded that. I was like, really? What? So, some examples of, so a differential equation basically involves a function and its derivative. Okay, so it involves a function and its derivative. Or maybe just the derivative. Function and its derivative, right? So in other words, we have a rate of change going on in there, right? That's what the derivative is. So some examples, dy by dx equals 2 over x. That's the first equation, and it represents the rate of change in, with respect to, change of y with respect to x. dh by dt is negative t plus 16, so this could actually be describing something physical quantities. So second equation could represent the rate of change in height with respect to time. Third equation could represent the rate of change in. Well, there is time, but yeah, it's not that. It's also how many degrees it is outside. Temperature, yeah, could be the change in temperature with respect to time, right? It's always about time, right? Because it's rate of change, so what's it going to change with respect to? If the differential equation is known, it's sometimes possible to determine the relationship between the variables themselves. So if we know that dy by dx is 2 over x, right, or we could say, we know that y prime is 2 over x, so what's y? Think carefully. 2 ln x, yeah. And we put absolute value around the x, right? Because 2 ln absolute value x, and to finish it off, plus c. If dh by dt was negative 10t plus 16, then what is a possible relationship between h and t? Okay, so if we know dh by dt, or h prime, let's call it, right? Then what's h? So negative 5t squared plus 16t plus c. Oh, now it gets fun. dt by dt, you can do this. It's a chain rule, right? Because you're going to need a function. Okay, so we're going to have a negative cos. Okay, but I want to get 24 pi over 365. Negative 12, right? So cap to negative 12 cos 2 pi over 365 t. Now, we'll learn ways, right? This is, we'll learn the unchain rule. This is chain rule, right? So if you can get it, great. If you can't, there is a procedure to follow, right? We'll learn that next unit in integrals. So you think about, okay, I've got the sine of 2 pi over 365t. When I do the derivative, this 2 pi over 365 is going to come out as a constant, right? But I want it to be 24, so I need a 12. But then the derivative of what gives me sine? Well, that's cosine, but cosine gives me a negative sign, so we put a negative sign in front of that. That's a different negative sign, not a negative sign. So we put a negative in front of the 12, right? And what are we missing on the end? Plus c. Go forward. What if we know the slope of the tangent line to the graph of f at any point x is defined by m is 2/3 x plus 13? Can we get an equation? An equation. Note and bolded. An equation. Not the equation. Yeah. A equation. An equation. So in other words, there are many equations, right? If we said the equation, then we're referring to there's only one solution. Okay, so what do we start with? Well, kind of like, okay, so we know that f prime is 2/3 x plus 13, or, we could say f prime of x. So what's f of x?
1/3
Yeah, so 1/3 x squared, right? So we got to get the 2 there, but we need the 1/3. Plus 13x. Plus c, so it says give me an equation, so f of x is 1/3 x squared plus 13x plus plus 1. Plus 1. Plus 7. Plus 22. Minus 17. Plus pi. Minus e. Okay. So anything, just any constant here, right? That's it. That's an equation. There are infinitely many of them. You could just go plus 0. You could just leave it as it was. Right? But we can add any constant. So, what's this say? The solution to a differential equation in two variables is an algebraic equation that relates the two variables. That equation can then be used to answer specific questions concerning the variables. As you can probably see already, the solutions will involve antiderivatives, being as we've just done about 5 of them. So, all right, solving differential equations involving initial conditions. All right, what if we have some initial conditions? So we're back with our old friend. dH by dt is negative 10t plus 15. Represents the velocity of a stone thrown from the top of a building t seconds after release. If the stone is 60 meters above the ground, 2 seconds after it was released, then determine when the stone will hit the ground. All right. What have we got? So we've got its velocity. We want an expression for its height, right? So what's the height? Negative 5t squared. Plus c. But wait, we have some information, right? We know the stone is 60 meters above the ground 2 seconds after it was released. So this is an expression for height. So we know that h of 2 is equal to 60. So we take that and we'll say that means that 60 is equal to negative 5 times 2 squared plus 15 times 2 plus c. So now we can find the equation which describes the height of this particular stone, which at a time of 2 seconds is 60 meters above the ground. All right, so what do we got? 4 negative 20 plus 30 plus c. So 60 is 10 plus c. So c is 50. Okay, so given a piece of information, wait, I missed something good.
Someone said 6.
6?
I think they divided
Oh, okay. 6. Well, okay. At least I can see how you can get that, right? It's when you get like really weird numbers. Like, how'd you get that? I don't know. Multiplied by. So our equation now, we have the equation, right? Negative 5t squared plus 15t plus 50. So we want to know when the stone will hit the ground. So when does the stone hit the ground? Yeah. So we need h of t equal to 0. Okay. So when the height is 0, stone's on the ground. So negative 5t squared plus 15t plus 50 is equal to 0. So what could we do? Yeah, we can just divide everything by negative 5, right? So remember, when we're doing derivatives and stuff, we want to factor that out, right? Because we need to take into account what's the sign of the derivative. Here we're just solving a quadratic. So divide everything by negative 5t squared minus 3t minus 10 is equal to 0. It actually does factor. So we have two solutions, but what do we do with one of them? We
Reject
reject the negative. And we say the stone will hit the ground. After 5 seconds. Okay. Easy peasy, right? And what did it all start with? It started with an expression for velocity, right? And we backed that up to get an expression for height or displacement. But then we had an initial condition that we allowed us to find the equation, or the particular equation we want. Okay, everybody good? The differential, oh, we've seen this one too. Differential equation dt by t is 24 pi by the It's the rate of change in daily average temperature in some Alberta town where t represents the average temperature little t days after January 1st. If the average temperature on January 1 is minus 6 degrees Celsius, then determine the average temperature halfway through the year. Okay, so one step at a time. We're going to need to get an expression for temperature, right? So what is temperature? Okay. Oh, we already did this one, right? Negative 12 cos 2 pi over 365 times t, right? I mean, all that says is that it's horizontally stretched by a factor of 365 over 2 pi plus c, right? Because we're given information on January 1st when t, little t is going to be 1. Right?
Days after.
Oh, days after. So on January 1st, little t is 0. Okay, so on January 1st, on January 1, t is equal to 0. So big T is negative 20 cos 0 plus c. Oh wait, big T is negative 6, right? We know that. Negative 6 is equal to negative 12 cos 0. What's the cos of 0? 1. Okay, so negative 6 is equal to negative 12 plus c. So c is 6. Yeah. One of those. It's like one kid last year, the only mistake on like the second cum or something was just taking 3/4 instead of 4/3, or just converting 3/4 to the wrong decimal, or 4/3 to the wrong decimal. Who?
That was Hannah.
Yeah, could yeah, it was.
She's still convinced about it.
There's nothing I could do. It was numerical response. Okay, so our equation is t is equal to negative 12 cos 2 pi over 365 t plus 6. Now, halfway through the year, what's going to be inside the brackets there? Okay, so let me ask you this. Halfway through the year,
Just pi. It'll be 365.
yeah, what's t over 365 equal to halfway through the year? 1/2, right? Because t is whatever, 150, 80, 187 and a half days. So this is equal to a half. Okay, times 2 pi, which is pi. So we end up with t is equal to negative 12 cos pi plus 6. Right? So halfway through the year, t over 365 is a half. Times 2 pi gives you just pi. Okay, what's the cos of pi? So t is 18 degrees Celsius. So halfway through the year, the average daily temperature, if this were accurate, which I have my doubts. But yeah. Halfway through the year, it's still the t over 360. Oh yes, that's true. It's not for a leap year. Speaking of which, how many possible years are there? Oh, I hear rumbling outside.
It might be the jet out of straight jet.
Yeah, okay.
No.
I want some lightnings.
You might get it. It's a Hornet, an F-18.
But I'm wearing white. I'm wearing shorts. It's like one thing that works.
I think you might have been.
My mother never said there was a no.
I think you're waterproof. Find the equation of the curve that passes through pi over 12. I've ridden my motorcycle home in the rain when I'm not prepared, and it's just, I mean, it's not comfortable, but because the water pools on the seat, and yeah, so anyways.
You gotta wear slippers.
Passes, I have waterproof pants and stuff. Passes through pi over 12, 2 root 3 if the slope of the curve at any point x is defined by secant squared 4x. Okay, what do we know? So let's go with this. Y prime is equal to secant squared 4x. Okay, the derivative of what gives me secant squared? Okay, so the derivative of tan 4x is going to be secant squared 4x times, well, times 4, which means we need 1/4 of, right? The reverse of the chain rule, right? So we know the function is derivative of sec squared, which is tangent, so tan of 4x, but that derivative is 4 times secant squared 4x. We want 1, so we throw a quarter in there. And at the end, plus c. Because we have information, right? We know that y is equal to 2 root 3, when x is equal to pi over 12. So we can now solve for c, getting the equation, right? So basically we're given the derivative in a piece of information. Okay, so 2 root 3 is 1/4 the tan of pi over 3. Okay, what's the tan of pi over 3? Is it just root 3? Pi over 3 is there, it's y over is there. It's root 3, right? Yeah, it's just root 3. Okay, so 2 root 3 is equal to root 3 over 4 plus c. So 2 root 3 is going to be 8 root 3's over 4. So c is going to be equal to 7 root 3 over 4. Okay? Let's do it. So 2 root 3 is 8 root 3 over 4. And then we're going to subtract the root 3 over 4. Gets a c. You see? So we go back to the original and we fill in the c. And we go look at your question again, because by now we've forgotten. Find the equation of the curve. Oh, that's it. That's the equation of the curve that does that. Here it is. When they say find x, and somebody says, here it is. Take that. Okay. Ready? We're just flying through this. Only 2 pages. Only 2 pages to go. Yeah, if you want me to get 4y. For why would you do that? No, why for would you do that? The area under the curve of f of x equals sine x cos x from a to pi over 2 is 3/8. Determine a if a is greater than 0. Okay, the area under a curve. What do we call the area under a curve? We've been calling it like call it f prime of x, right? Is the area under the curve? No, the area under the curve is f of x, capital F of x. Yeah, so okay, we've got, yeah, so we need the antiderivative. We need capital F of x, right? Practice quiz 7, modified. That's okay, it's in the recording and everything now. All right, so what is going to give me sine x cos x? Yeah. Yeah, 1/2. Half of that, right? Okay, so the derivative of sine squared x, or sine of x squared, is 2 sine x cos x, right? So we're going to take a half of that. Right? Like, how do we get this sine x cos x? Well, sine squared x, right? So 2 times, right? Derivative of the outer function with respect to the inner, so 2 times sine x times the derivative of the inner, which is cos x. Right? But we want just a 1 there, so we put a half in front. Okay? Plus c. Okay. So the area here is going to be f of pi over 2 minus f of a. Actually, you know what? Let me go a little more general. Area is f of b minus f of a, right? On an interval ab. So the area we were given is 3/8. The b value is pi over 2, and the a value is just plain old a. So now we can plug in. So 3/8 is equal to 1/2 sine pi over 2 quantity squared plus c minus 1/2 sine a quantity squared plus c. So sine of pi over 2 is 1. 1 squared is 1. So we're going to get a half. Okay, plus c. We're not going to write the plus c. It's going to subtract off. And then minus 1/2 sine of a squared. Okay, so we'll just go right across. So first step is to do what to both sides? Not yet. Well, okay, you could, but yeah. Let's subtract a half, right? Subtract 4 over 8. So what's that going to give me? Okay, then we're going to go through and multiply by -2. All right, so that'll give me 1/4 is sine of a squared. So what's the sine of a? Plus or minus 1/2. In our domain, which is from 0 to pi over 2, a will be pi over 6. Okay. It's also 5 pi over 6, 7 pi over 6, 11 pi over 6. But remember, our domain is from 0 to pi over 2. And so, since a is less, 0 is less than a is less than pi over 2. A is pi over 6. Done. Fast lesson. Wow, okay, I know. There's still 2 more to go, but it's still moving quick. Besides these last two are pretty. A particle moves in a straight line and has an acceleration given by a of t is 6t plus 4 centimeters per second squared. Its initial velocity is -6 centimeters per second, and its initial displacement is 9 centimeters. Determine the equation for the position function s of t. So, a of t. The acceleration is the derivative of the velocity function, right? Which is equal to, so we were given that, 6t plus 4. Okay, so what's v of t? So let's just go with 3t squared plus 4t plus c. Okay, now information comes in, right? It's initial velocity, so what does that mean?
When t is equal to 0.
Yeah, so v of 0 is negative 6. So negative 6 is equal to 3 times 0 squared plus 4 times 0 plus c. So c is negative 6. So now we have velocity. What's velocity equal to? Derivative of position. So v of t, which is s prime of t, is 3t squared plus 4t minus 6. So what's s of t?
T cubed plus 2t squared minus 6t plus
We'll pause for a moment. Start writing stuff down. But what do we know? You know, it's initial displacement. So going back up top, we know s of 0 is equal to 9. So 9 is equal to 0 cubed plus 2 times 0 squared minus 6 times 0 plus c. So c is 9, and then s of t is t cubed plus 2t squared minus 6t plus 9. And that's what we were supposed to find, right? An expression for the displacement function, or find the displacement function. Yep. Yep. Guaranteed. Because they're easy. Easy marks. Right? No, and I can't believe it. Would you seriously put these really easy questions on that? Yeah, we will. So let's say it's something like this, right? It's just going to run through the whole thing again. An object is thrown from the top of a 140-meter tall building. Apparently we like throwing things, stones, whatever. With an initial velocity of 15 meters per second. Okay, so if the acceleration due to gravity is approximately negative 10 meters per second squared, then determine. All right, so we know what? V of 0 is 15. S of 0 is 140. And A of t is negative 10. Well, negative 10. So little a, an expression for the velocity in terms of t seconds after the object is released. Okay, so acceleration, a of t, is equal to v prime of t is equal to negative 10. Therefore, v of t is equal to negative 10t plus c. And at this point, having written the v of 0 equals 15 there, I'm okay with you going v of t is equal to what? Yeah, equals 10t, sorry, negative 10t plus 15. Okay, so they gave us the expression for acceleration. They gave us two initial conditions. We know the drill, right? We just ran through one like this. What's the velocity of the object 1 second after its release? Okay, well, we got an expression for velocity. So v of 1 is equal to negative 10 times 1 plus 15, which is 5. 5 what? Meters per second. Okay, so 1 second after it's released, it's still going up, right? Still going up at 5 meters per second. It slowed down. It was initially going up at 15. But. All right, what's C? Because I can't see C. The maximum height of the object. When do we get the maximum height? Yeah, so when the velocity is 0, right? So we throw it up with an initial velocity, it's slowing down, reaches the velocity of 0, which means it's peak. It's going to start heading down. So C, we need V of t equal to 0. Okay, so 0 is equal to negative 10t plus 15. So what's t? 1.5, 3 over 2, whatever you like. Or 3 over 2. What we're supposed to actually find? Okay, the max height. Okay. Oh, well, we don't have an expression for height yet, though, right? So how do we get the height? Okay, so we have the velocity, right? So v of t, which is equal to s prime of t, is equal to negative 10t plus 15. So s of t is equal to plus 15t. Let's go with plus c. Yeah, no, wait, I can do that at the end of the lesson. Yeah, I've never done it. Wait till the end of the lesson. What do we know? So we're going to go with s of t, given our initial condition, is negative 5t squared plus 15t plus 140. Okay, if you want to know why, just look up in the top right where we said s of 0 is 140, and you're not going to put it. So, on a quiz or test, you can do that. Okay, but show this first. Write it with the plus c, and then replace that. And we were actually supposed to evaluate this, right? We're supposed to find this when, find what the height is. So we need s of 3 over 2 is negative 5, 3 over 2 squared, plus 15, 3 over 2, plus 140. All right, what do we got? 9/4, negative 45 over 4. So it'll be 45 over 2, so let's call it 90 over 4. Plus 90 over 4. Let's call this 560 over 4. You can multiply 140 by 4, trust me. Just break it out. 4 times 100 and 4 times 40. Add them together. All right, so this is going to be 45, so we're going to get 605 over 4. Which is what, 151 and a quarter meters, right? Well, 4 goes into 600, 150 times, and into 5, 1 and a quarter times. All right, oh, are we there yet? No. Well, okay, that's C, but now we got D. The velocity of the object when it's 50 meters above the ground. Wait, everybody got this? Okay. D. Velocity when it's, so we have an expression for velocity, right? When it's 50 meters above the ground. So, okay, when, what do we got to find? We got to find t when s of t is 50, right? So we need t when s of t is equal to 50. Okay, so what was s of t? Okay, so negative 5t squared plus 15t plus 140 equals 50. All right, solve it. It factors, just so you know. Just you don't need to use quadratic formulas in here. Everything is a nice number. It's all integrals. Now, let's get that 90 first. All right, t squared minus 3t minus, is it That's my weakness in the multiplication tables. It's like 120 is 15 times something. Okay, so that factors pretty easily, right? So show it and then reject it. Okay. Borrow a magnet. Do you do it on purpose?
I have a special magnet. I have a little magnet.
It's really a motor project. Why do you have to use a new magnet?
They're broken, but
They're strong. They're really, really strong.
Here's a tea. I can give it back to you.
you don't even need it.
It's going forever.
It might spark up.
That one.
It might. That's really strong. It might spark up.
Where
They're
you goggles?
neodymium. They're really strong.
Don't do it.
No.
Do you want to see a video of our motor exercise?
Oh, well then do it. It won't hit that stick.
Yeah, it's like supposed to be there.
Oh, shocking that this just. Here, let me try.
Oh my gosh.
You're not. You throw his magnet, it'll stick to the
It's
board.
recording, by the way.
Oh, it's recording. Well, I'm not backing it up. All right, so reject the -3, and we have 6 seconds. Well, what were we finding? Oh, we need t. No, velocity. Okay, so now we want v of 6. So v of 6 is -10 times 6 plus 15, which will be -45 meters per second. So when it's 50 meters above the ground, it's going down at a velocity of 45 meters per second. Watch direction on stuff. Okay? So just be aware of directions and how things are changing in relation to, right? Are they things getting closer to each other, further apart? All right. That was D. E, the velocity object as it hits the ground. So when it hits the ground, what's going on? Height is 0. Okay, so E, we need t when s of t is equal to 0. Right? So we need the displacement to be 0. All right, and luckily that's level here. So -5t squared plus 15t plus 140 equals 0. Dividing through by -5. 140 is what? 28. 28. So show the -4 and just cross it off, right? We can't have negative time. Okay, t is 7, and but we were looking for velocity, right? So v of 7 is -10 times 7 plus 15. -55 meters per second. So when it hits the ground, it is velocity, downward velocity is 55. It's hitting pretty good, right? 5 meters per second. Okay, so right there, pen drop. You could hear a pen drop.